What is refractive index? Well, consider that an incident light ray is traveling in the vacuum. Let it hits the surface of a glass and enter into it. We know that light is refracted towards the normal in this case. The speed of light in the vacuum is 3 into 10 to the power 8 meter per second, while the speed of light in the glass is 2 into 10 to the power 8 meter per second. So we say that the speed of light in the vacuum is high and the speed of light in the glass is slow. Now if I ask you why the speed of light is high in the vacuum and slow in the glass, then the answer is simple. It is because the vacuum is optically rarer medium. It means that vacuum shows less resistance to the speed of light, while glass is optically denser medium. It means that glass shows more resistance to the speed of light. Thus, the first fact is that if a medium is less optically denser, speed of light is high. The second fact is that if a medium is more optically denser, speed of light is slow. Now listen carefully. How we can measure optical density of a medium? Well, refractive index measures the optical density of a medium. Let me repeat it. Refractive index measures the optical density of a medium. So refractive index is nothing but the optical density of a medium. For example, I am interested to find that how much speed of light slows down in glass with respect to vacuum. So I will find the ratio of speed of light in a vacuum to the speed of light in a glass. For instance, speed of light in a vacuum upon speed of light in a glass. We know that the speed of light in a vacuum is 3 into 10 to the power 8 meter per second and the speed of light in a glass is 2 into 10 to the power 8 meter per second. After calculation, I get 1.5. What does this 1.5 mean? Firstly, it shows the optical density of a glass relative to vacuum. Secondly, it shows that speed of light is 1.5 times slower in glass than vacuum. Let me repeat this important point. It shows that speed of light is 1.5 times slower in glass than vacuum. Hence, we therefore say that optical density and refractive index are same thing, are two faces of the same coin. So this 1.5 is also called the refractive index of the glass. Therefore, we define refractive index as the ratio of the speed of light in a vacuum to the speed of light in a specific medium is called refractive index. It is denoted by N. Mathematically, we write refractive index is equal to speed of light in a vacuum upon speed of light in a specific medium, or N is equal to C upon V, where C is the speed of light in a vacuum, which is a constant value, and V is the speed of light in a specific medium like glass, water, etc. Remember that this refractive index is also called absolute refractive index. Also noted down that when refractive index N is greater, medium is more optically denser and speed of light in it will be slow. Secondly, when refractive index N is smaller, medium is less optically denser and speed of light in it will be high. Now let me teach you that how we can solve numerical problems of refractive index. For example, the speed of light in a diamond is 1.25 into 10 to the power 8 meter per second. Find its absolute refractive index. Firstly, let me draw a freehand diagram so that you could easily understand it. Let the incident light ray is traveling from the vacuum and entering into the diamond. We know that the speed of light in the vacuum is C is equal to 3 into 10 to the power 8 meter per second, and the speed of light in the diamond is given V is equal to 1.25 into 10 raised to the power 8 meter per second. As we learned in the previous slide that refractive index N is equal to C upon V, where C is the speed of light in the vacuum and V is the speed of light in the medium like diamond. I plug in all these values in this equation. After calculation, I get 2.4. So the refractive index of the diamond is 2.4. What this 2.4 refractive index of the diamond means? Well, it means that the speed of the light is 2.4 times slower in the diamond than the speed of light in the vacuum. Thus, by this way, we can easily find the absolute refractive index of any medium. Here, let me teach you two bonus MCQs. Refractive index is unitless or it has no unit. If you ask me why, then it is because refractive index is a ratio between two similar quantities. For example, the unit of speed in numerator and the unit of speed in denominator cancel out. We therefore say that refractive index is unitless or having no unit. Secondly, absolute refractive index is always greater than 1. If you ask me why, then it is because in case of absolute refractive index, light always travels from the vacuum or rarer medium into denser medium like glass. So the speed of light always slow down in the denser medium, and absolute refractive index is therefore always greater than 1. Finally, let me quickly teach you the concept of relative refractive index. Let's consider a glass and water. Let an incident light ray is traveling from the glass into the water. So it is refracted away from the normal in this case. Let glass is first medium and water is second medium. The speed of light in the glass is 2 into 10 to the power 8 meter per second, while the speed of light in the water is 2.25 into 10 to the power 8 meter per second. I am interested to find the refractive index of water relative to glass, or I am interested to find the refractive index of the first medium relative to second medium. We know that absolute refractive index N is equal to C upon V, where C is the speed of light in the vacuum and V is the speed of light in a medium like glass. So we always put the relative medium like vacuum in the numerator, while we put the medium like glass in denominator, in which we find refractive index. So N is equal to speed of light in first medium like glass upon speed of light in second medium like water. Plug in all these values in this equation. After calculation, I get N is equal to 0.8. So the relative refractive index of water with respect to glass is 0.8. Also remember that relative reflective index is either smaller than 1 or relative refractive index is greater than 1 depending upon the relativity of two media. But refractive index, both absolute refractive index and relative refractive index will never be equal to 1. I hope that you have learned all these concepts.